how do we write these formulas? So we can do this crisscross rule. So you write each element, now we'll turn them into ions. So you write each ion down, write their charges, and then you crisscross. So you take, so magnesium. Magnesium has a +2 charge, and nitrogen has a -3 charge. So I take this superscript, this charge, and I just put it down here to be the subscript on the magnesium, and the +2 to go down there. So I get Mg3N2. So if you want to draw a picture of what this really looks like, all right, so that means that subscript tells me how many of each one I have. So I have 3 magnesiums, and each magnesium has a +2 charge. So that's a magnesium, and this is a magnesium. Whoa. So I have 3 of these. So what's my overall positive charge here? +2, +2, +2, that's a +6 charge on that side. And then I have 2 nitrogens. So what's the charge on nitrogen? Nitrogen goes -1, -2, -3. So nitrogen is -3. And this is nitrogen with a -3. So I have 2 of those. How do I know I have 2 of those? Because I have a subscript 2 here. So I drew 3 circles here, 3 magnesiums, +2, 4, 6. That's a +6 charge over here. And I have 2 nitrogens. Each one has a -3 charge. So -3, -3 is -6. +6, -6 is neutral. So I know I need 3 magnesiums for every 2 nitride ions. And this is because the compounds have to be electrically neutral. So the amount of positive charge has to equal the negative charge. So the trick is just trying to figure out what these subscripts are. How many of each one do I need? So the charge on the cation becomes the subscript on the anion. The charge on the anion becomes the subscript on the cation. And then the last thing you have to do, and this is, that'll get you the right answer 80% of the time. The last thing you have to do is look at those 2 numbers and make sure that you have the empirical formula, that you have the lowest whole number ratio. If not, divide them by their greatest common factor. So we'll do a couple examples of that. All right, so in this example, I'm actually giving you the charges so you don't have to look them up. This is just focusing on actually writing the empirical formulas. All right, so what do we do there? We have sodium, which has a positive charge. The cation always comes first. The cation, the positive one's always going to come first. The anion's going to come next. That's PO4 with a 3-. This thing is called a polyatomic ion, which they're going to be listed next. That's phosphate. We're going to have to memorize all these. And you'll see why that's important later. So now you treat that as 1 ion. That means this P with O and 4, that thing is, treat it like 1 ion. If I were to put this, I have 1 circle there, I have 1 of those. Now what I'm going to do is I'm going to take this 3, that becomes my subscript down there. This is a +1, so that's just going to be a 1 on that side. So when I put all this together, I get Na3PO4. And then since I only need 1 of those, I don't put it there. I don't want to put a 1 there because that makes it look like I have 41, 41 oxygens. I just want 4 oxygens. I did the same thing over here. So now if I did my crisscross rule, or if you want to draw this out again, if you want to think about what it looks like, I'll draw it over here. So I have sodium with a plus, and I have sodium with a plus, and sodium. I have 3 of those, right? So I have 1. Oh boy. I have 1, 2, 3 of those. And then I have 1 phosphate. So I have +3, and then I have a phosphate of PO4 with a -3 charge on that side. So +3, -3 gives me neutral. It gives me a 0. Now for the rest of these, take a minute, you work on them, do some crisscrossing, see what you get. You have zinc 2+, and sulfate 2-. If you crisscrossed them, you'd get this. You get Zn2, SO4, 2, but I have 2 and 2. I could divide them both by 2, and I get zinc sulfate SO4. Now, I don't need any parentheses because I only want 1 of those. You might look at that and just say, oh, I have a +2 charge and I have a -2 charge, so I know that that's going to cancel, so I just get zinc sulfate. That's my final answer there. This one was Na3PO4. And then down here, if you want to do the same thing, you can write out I have iron, and I have CO3, my 2 minus that I had up here, I'm just going to put it down here. And now I have 3 over here, but I don't want to put it just there. I need to put this in parentheses to say I have 3 carbonate ions. If I just put a 3 there, it looks like I have 1 carbon and 33 oxygens. If you want to draw this out, I have an iron, I have 2 irons, I have another iron over here. Each one has a 3 plus charge. So my total charge, and you don't have to draw this every time, this is just to emphasize that you want neutral compounds. So I have a plus 3 plus 3 gives me plus 6. And carbonate, I'm going to have 3 of those, so I have 3 CO3, CO3, and CO3. Each one has a 2 minus charge. So I have 1, 2, 3 times -2 gives -6, and they're going to cancel. And then finally, calcium 2 plus, oxygen 2 minus. You might already look at that and say, I don't want Ca2O2. If I just crisscross, that's what we get. I have to divide by the smallest number to get the empirical formula. I just get CaO. And down here, I have aluminum, and I have 3 chlorine, so that plus 3 is going to go down here. I have a -1, so I just have 1 there. I don't even write the 1. All right, so those are your final answers on how to do the crisscross. Now, some of these ions you're just going to have to memorize. If they're monatomic ions, just 1 atom. If it's in group 1, it's a +1. Group 2, +2. So those are your cations. The cations, again, these are the positive ones. Some cations are going to have more than 1 charge. So something like copper, you can see copper over here. We call that the copper 1 ion. And down here we have copper with a +2 charge. That's called the copper 2 ion. That happens a lot with the transition metals, and so we'll have to name those differently. We'll have to specify, do I have copper 1 or copper 2, because that'll change the formula. We only have 1 polyatomic cation that we have to know. Right there, there's a polyatomic cation. It's NH4+. That's called the ammonium ion. All right, I gave you a little list down here of the polyatomic ions that you should memorize. Those are cations. Anions, so our anions, remember, those are going to be our non-metals. So remember, we had +1, +2, +1, 2, 3, and then working backwards, skip the noble gases, and then we have -1, -2, -3. So halogens here, these are your -1s. This is a polyatomic ion, the cyanide ion, hydroxide ion. We'll have to know those two. You don't have to worry about peroxide. Oxide is here, sulfide, these are your -2s. And then -1, you have some more polyatomic ions over here, and more polyatomic ions over here. So the ones that I really want you to memorize, and I want you to know their formula, you need to know their charge, and you need to know their name. The ammonium ion, NH4+, hydroxide, OH-, nitrate, NO3-, chlorate, ClO3-, cyanide, acetate, carbonate, sulfate, and phosphate. So I put these in a specific order so you can kind of memorize them by charge, group them together. Whenever you're memorizing something, it's a lot easier if you memorize them in groups. That's what I've always found anyway. So those all have +1, these have -1, these are all -2, and that's a -3. It's really tempting to just kind of look at the ending and say, okay, anything that ends in 8 has 3 oxygens. I wish that'd be great, but no, phosphate has 4 oxygens and sulfate has 4 oxygens, so it's really make up some flashcards and memorize these. You need to know the charges and you need to know the formulas. There's a lot more in this table. There are even more tables of polyatomic ions. These are the most common ones. These are the ones you're going to see again in Chem 2. These come up again. Don't just say, whatever, I don't have to memorize anything. Memorize them. You have to memorize them. Please memorize them. Naming is really, really, really hard when you don't have these already memorized. So we'll stop there and you memorize these, and then we'll learn how to name next time.